Welcome to this presentation on Java programming. Today, we'll learn how to write a program to calculate the sum of a mathematical series using functions in Java. The series we are working with is S equals 1 times 2 plus 2 times 3 plus 3 times 4 plus up to n terms. By the end of this session, you'll understand how to design the logic, write the code, and implement a user-defined function to solve this type of problem efficiently. Let's begin by understanding the task. We are required to write a Java program that finds the sum of a series using a function named sum, which accepts an integer argument. The series is defined as S equals 1 times 2 plus 2 times 3 plus 3 times 4 plus up to n terms. In the main program, we'll ask the user to input the number of terms. Then, we'll call the sum function to calculate and display the final result. Now let's look at the step-by-step algorithm for solving the problem. Step 1. Start the program. Step 2. Define a method called sum that takes an integer n as input and returns the sum of the series. Step 3. Inside the method, use a loop to calculate each term in the format I multiplied by I plus 1, and add it to the total sum. Step 4. In the main method, prompt the user to enter the number of terms, then call the sum function and store the result. Finally, display the calculated sum to the user. Step 5. End the program. In this slide, we begin our Java program by creating a class called SeriesSum. Within the class, we define a method named sum that accepts an integer parameter n. This method is responsible for calculating the sum of the series up to n terms. We declare it as static because we are calling it directly from the main method, which is also static. In Java, a static method belongs to the class rather than an instance of the class, so it can be called without creating an object. Inside the method, we initialize a variable s to store the total sum. We then use a for loop from 1 to n, and in each iteration, we compute I times I plus 1, and add it to s. After the loop finishes, the method returns the final value of s to the caller. Now, let's look at the main method where the program begins its execution. We create a scanner object to take input from the user. The user is prompted to enter the number of terms, which is stored in the variable n. Then, we call the sum n function we defined earlier and store the returned result in the variable result. This result represents the sum of the series up to n terms. We then display the result using system.out.println. Finally, we close the scanner object to free system resources. This completes the entire program flow, from input to processing and output. In this slide you will get the full program link which you can execute the entire program. Also, program link is available in the description box. This slide explains the different variables used in our program. First, we have n, which is an integer variable that stores the number of terms the user wants in the series. Next is I, the loop counter used to iterate through each term in the series. Then we have s, an integer variable that accumulates the sum of the series as we compute each term. Finally, result is the variable that stores the value returned by the sum function and is used to display the final output. This table helps us clearly understand the purpose and data type of each variable in the program. Here's a sample output of the program. When the user enters the number of terms as 5, the program calculates the series 1 times 2 plus 2 times 3 plus 3 times 4 plus 4 times 5 plus 5 times 6. That is, 2 plus 6 plus 12 plus 20 plus 30, which gives the final sum of 70. This output confirms that the logic and function are working correctly and the series is being computed as expected. Let's quickly recap what we've learned. We wrote a Java program that calculates the sum of a mathematical series using a user-defined function. The series followed the pattern S equals 1 times 2 plus 2 times 3 plus 3 times 4, and so on, up to n terms. We used a static method named sum, which takes an integer input and returns the total sum of the series. Inside the method, we used a loop to calculate each term and add it to the cumulative total. The main method handled user input, called the function, and displayed the result. Finally, we understood the purpose of each variable with the help of a variable description table. Before we conclude, let's highlight some key points to remember. First, we use static methods when we want to call them directly from the main method, which is also static. Second, using functions makes our code more modular and reusable, a good practice in any programming language. Third, loops are powerful tools that help automate repetitive tasks, such as calculating terms in a series. Fourth, always remember to close input objects like the scanner to prevent memory leaks. And finally, breaking your program into logical steps, as we did, makes coding easier and debugging faster. Thanks for watching. Documentation containing question, algorithm, Java program, variable description table, VDT, sample output is also available in description box of this video. Don't forget to subscribe if you are using this for your school or college projects. Happy learning!